Today we'll be working on lesson 6.8b, graphing rational functions in standard form. Remember always before you start graphing rational functions, you have to decide whether the function is given to you in its transformed form or standard form. If it's in the transformed form, remember x equals h is going to be your vertical asymptote, which is going to move your graph either right or left. K is going to be your horizontal asymptote, and that's going to move your graph either up or down. So as you can see, there's a fraction with a number on the outside of the fraction, and that's going to be your transformed form. Standard form, you're going to have only one fraction. There's no k. Most likely there's an x on the top and on the bottom. Sometimes there's no x on the top. Sometimes the higher power is going to be on the bottom. Sometimes the higher power of the fraction is going to be on the top. So this is what we're going to be discussing in standard form. So in order to be graphing that, you have to find the horizontal asymptote, the holes in a function, and that's a new term, a vertical asymptote, an x-intercept, and the y-intercept. So let's go ahead and start with horizontal asymptotes, and let's focus on finding horizontal asymptotes in a standard form. To do that, I would like you to meet our three clowns, Bobo, Butno, and Bosco. What does Bobo mean? It means if you look at the fraction, look at the x's having the power on the top. What's the highest power? 1. Look at the x on the bottom of the fraction. What's the highest power? It's 2. So the top power is 1, the bottom power is 2. So as you can see, you have big on bottom. So BOB stands for big on bottom. Then the O means 0. Y equals 0 is going to be my horizontal asymptote. So if the higher power is on the bottom, big on bottom, y equals 0 is going to be your horizontal asymptote. Now let's meet Butno. It means big on top. NO means no horizontal asymptote. It means if the higher power is on top, then you will have no horizontal asymptote. In this case, the power on the top of the fraction is a 2. So as you can see, you look at the x having the higher power on the top. So that's a 2. The power on the bottom is a 1. So as you can see, I have the bigger power on top. So big on top, then there's no horizontal asymptote. And the last clown is Bosco, means both. BO stands for both. The same. So S means same. What does that mean? If you look at the top of the fraction, the power of the x is 1. If you look at the bottom of the fraction, the highest power is also 1. So both are the same. So both, Bosco means BO, both, same powers. It means the y equals to the coefficients of these two. For example, if you look at this one, 8x to the power 1, what's the coefficient of that? 8. Now, look at the bottom. What's the coefficient of that? 4. So 8 over 4 equals 2. So if both are the same, having the same power, then y equal to the coefficients, division of the coefficients, 8 divided by 4, and that's going to be your horizontal asymptote. Now let's try to practice this. Now, as I can see, this is a Butno. So since the bigger power is on the top, 3 and this is 2, then NO stands there's no horizontal asymptote. Okay? Now let's look at the second example. I can see that there's a Bosco over here because the power of the x is 1 and here it's 1, so both are the same, Bosco. So y is equal to the coefficients. The coefficient over here is 2 and here it's 1. So my y equals 2 over 1, which is 2. So y equals 2 is going to be my horizontal asymptote. Now let's look at the third one. The higher power is on the bottom. So this is a 1 and this is a 2. So big on bottom, so Bobo. And Bobo tells me big on bottom, 0. So y equals 0 is going to be my horizontal asymptote. Now let's look at the fourth one. The top has no x, so I'm going to consider the top power to be 0 and then the bottom power to be 1 if there's no x on the top. So the power would be 0. So as you can see, the higher power is on the bottom, so Bobo. So it means y equals 0 is going to be my horizontal asymptote. And this is how you find the horizontal asymptote, using the clowns. It's just a way for you to remember the horizontal asymptotes. Now, and see how can we find the rest. So what else do we need to find? We need to find the vertical asymptote, we need to find the x-intercept, we need to find the y-intercept, and we need to find the whole of the function. Now in order to do that, you have to factor the top of the fraction and the bottom of the fraction. So let's go ahead and start with that. Okay, so let's start with now let's go ahead and practice finding all of these things to be able to graph irrational functions in the standard form. So let's look at the standard form. From a standard form, I can find the y-intercept and the horizontal asymptote. So let's go ahead and find the horizontal asymptote first. Now as I can see, I have the power on top to be 2, the power on bottom to be 2. So they are the same. So I think of Busco, the clown Busco. So I know that my y-intercept is going to be the division of the coefficient. So I have a coefficient of 1 over here over 1. Then y equals 1 would be my horizontal asymptote. Now to find the y-intercept, it's going to be the constants that you see on the top and the bottom of the fraction. So the top constant is going to be -4 over the bottom constant, which is 6. So these two numbers. And then if you can simplify, you can divide by 2, so you are left with -2/3. Then my y-intercept is going to be 0, -2/3. So remember that the y-intercept is a point having x equals 0. So to find the y-intercept, you can look at the division of the constants, -4 over 6 always. For the horizontal asymptote, you think of the 3 clowns we discussed earlier, and in this case I can see that the top power and the bottom power is the same. So Busco, it means y equals to the coefficients, so 1 over 1, which is 1. Now, this is what I can find from the standard form. Now let's move on and try to factor the top and the bottom of the fraction. So I have to write it in factored form. So x squared minus 4, that's the difference of 2 squares. So we have to factor it using x minus 2, x plus 2. And the bottom of your fraction is going to be x squared plus 5x plus 6. So you have to think of two numbers that would multiply to give me 6 and add to give me 5. And these are 3 and 2, because 3 times 2 is 6, and 3 plus 2 is a 5. So my two factors are x plus 3 and x plus 2. So remember, in order to find the rest, which is the whole of a function and the vertical asymptote, you have to be able to factor the top and the bottom. Now, after you factor, you have to think and look at your factored form closer. Now, is there anything I can cancel? I can cancel the x plus 2. So when I cancel x plus 2, what I'm going to be left with is the simplified form, x minus 2 over x plus 3. That's going to be my new function. So I canceled out x plus 2 from top and bottom, and I'm left with x minus 2, x plus 3. So that's going to be my factored form, and this is going to be my simplified form. Now, whatever I canceled, it's x plus 2, and that's going to give me the whole of the function. In order to find, so the whole of a function is basically a point having an x and a y. To find the x of this point, you look at the factor that you just canceled out, and you set that equal to 0. X plus 2 equal to 0. Now to solve for x, you subtract 2 from both sides, so x is equal to -2. So that's going to be the x coordinate, -2. Now to find the y coordinate of this whole, I have to plug in whatever x value I got in the simplified form. So let's go ahead and do that. So you plug in -2 for x, you get -4 on top, and 1 on bottom, so that's a -4. So the whole has points or coordinates of -2, -4. It means if I try to graph this, I look at the coordinate system, I find -2, and then I draw a circle over there. So I would remember that if I ever want to graph my function, let's say, is going to jump over the hole and it's not going to go through it, okay? So this is how you find the whole of a function. Now to find the vertical asymptote, you look at the bottom of your factored form, and you can see that there's a factor that you did not touch yet, which is x plus 3. You set that equal to 0. You subtract 3 from both sides, so x equals negative 3 would be your vertical asymptote. So think about it again. The factor that cancels out will give you the whole of the function. The factor that's left on the bottom of the fraction will give you the vertical asymptote. Now to find the x-intercept, you look at your simplified form, and I can see I have x minus 2 on the top. You set that equal to 0, and you solve for x. So x equals 2 would be my x-intercept. It means my point is going to be 2, 0, and that's going to be my x-intercept. This is how you find all of these values, and all of these will help you graph your function. Now to find the range, you have to look at your horizontal asymptote, which is in this case y equals 1. You also have to look at the whole. In this case, the whole of the function is negative 2, negative 4. So let me write it down. So what's going to affect your range is going to be the horizontal asymptote and the y coordinate of the whole. So let's put them in order. Then my range is going to be from negative infinity. At negative 4, it's going to skip that. And then again from negative 4 to 1. And then from 1 infinity. So basically it's everything from negative infinity to infinity except negative 4 and 1. So I have to split my range at these points. Now to find the domain, you have to look at the vertical asymptote, which is x equals negative 3 in this case. You also look at the whole. The whole has points negative 2, negative 4. It means the x equals negative 3 is going to affect my domain, and the x of the whole will affect my domain. It means it's going to be everything from negative infinity to infinity except these 2 points, or 2 numbers. So negative 3 to negative 2, and then negative 2 to infinity. So everything except these 2 numbers. Example, which is x squared plus x minus 2. In order to be, let's go ahead and find the horizontal asymptote first, since we can use one of the clowns to help us find it. So here, where's the higher power? It's on top. So that's a botno. Just write it down to help you remember. Botno means that there's no horizontal asymptote. Okay. Now, in order to find the rest, we have to go ahead and factor the top. So you have to think of 2 numbers that multiply to give me negative 2 and add to give me 1. So 2 numbers that would multiply to give me negative 2 and add to give me 1. And these 2 numbers are 2 and negative 1. So I'm going to put x plus 2 on top and x minus 1 over x minus 1. I cannot factor that, so I'm going to keep it the same. So step number 1, remember, always factor the top and the bottom if you can. Now let's look closer. Can I simplify anything from the top and the bottom? There's an x minus 1 on the top, x minus 1 on the bottom. It means x minus 1 cancels out, and I only have x plus 2 left. So that's the rest of my function. So I went from something like this to something like this. How did I do that? You factor the top and see if you can cancel something out. If you can, then you go ahead and write the simplified form at the end. Now, whatever you canceled will give you the whole of your function. So what did I just cancel? I canceled the factor x minus 1. So you set it equal to 0 and you solve for x. How do you solve for x? You add 1 to both sides. So you end up having x equals 1. Keep that in mind. It means the whole of this function have an x equals 1. Now, a whole basically is more like a point. So it will have coordinates, x and y. I just found the x of the whole of the function. Now we have to find the y. How do you find the y? You plug in So write that down so you would remember. Plug in the x that you just found in the simplified form. So what's the simplified form that I just got? I cancel out x minus 1, so I'm only left with x plus 2. So y equals x plus 2. So let's zoom in so we can write down. I just found x to be how much? 1. So I need to plug in 1 for x. That gives me y equals 3. It means that the whole of this function is going to be the whole of this function, so remember y equals 3. It means the whole of this function is going to be a point having coordinates 1 and 3. So that's the whole of the function. To graph that, let's go to the graph. It means I look for 1, 3, which is 1, 2, 3. It's going to be somewhere over here. So what I'm going to think of is that there's going to be a hole in this function. It means when I'm graphing and I reach that point, I have to skip this point and move on. So there's a hole in this function. Okay? Now, so let's review what we just did. From the factored form, whatever you cancel out, that's going to give you your x coordinate of the whole. From the simplified form, you can get the y coordinate of the whole of the function. Okay? Now, what else can you get from the factored form? From the factored form, you can also get the vertical asymptote. So look at the bottom of the fraction. Do I have any other factor left? After I canceled x minus 1, there's nothing left. So there is no vertical asymptote. Okay? Now, so let's review. There is no horizontal asymptote and no vertical asymptote. There is no horizontal asymptote because I have the higher power on top, but no, so no horizontal asymptote. I do not have a vertical asymptote because there's no factors left on the bottom. Whatever cancels out will give me the whole, so there's no vertical asymptote. So how do you find now the zeros, the x-intercepts? To find the x-intercepts, you have to set the top of the fraction equal to 0. So let's write that down. You have to set the top of the fraction equal to 0. Now, think of it as x plus 2 over 1, so the top of the fraction is x plus 2. I'm going to set x plus 2 equal to 0. And I solve for x. So x equals negative 2 is going to be my x-intercept. It means I know that my graph is going to touch the x-axis at negative 2. So again, how do you find the x-intercept? You set the top of the fraction equal to 0 and you solve for x. This is how you find the x-intercept. How do you find the y-intercept? You can find it from the standard form. Basically, what you need to do is you look at the constant on the top of the fraction. What's the constant? Negative 2. So you take negative 2 over. And then you look at the bottom of the fraction and you ask yourself, what's the constant on the bottom? Negative 1. And then my y-intercept is going to be negative 2 over negative 1. So basically these two, negative and a negative will become positive. So 2 over 1 is just a 2. And that's going to be my y-intercept. And remember, y-intercept is a point having x equals 0. And it's going to be 0, 2, so that is my y-intercept. Now for the last problem on our notes. To find the y-intercept, as usual, you look at the standard form and you take the constants. So 12 divided by negative over 6 would be negative 2. So y equals 12 over negative 6, which is negative 2. So 0, negative 2 would be my y-intercept. So let's go ahead and plot that. That's going to be my y-intercept. Now, as for the horizontal asymptote, I have to check which one of the clowns would be working with me over here. Now, if you look at the top of the fraction, the power is a 1. The bottom of the fraction, the power is 2. So I have Bobo, big on bottom, So y equals 0 would be my horizontal asymptote. So let's go ahead and show that. It's going to be my x-axis. I'm going to label that in dashed line. Okay, so y equals 0 is going to be my horizontal asymptote. So let's go ahead and move on. Now I have to change the standard to a factored form. I have to factor the top and the bottom. So if you look at the top, there's a 4 in common, so I'm going to take 4 on the outside, and then what's going to be left is x plus 3. Now if you look on the bottom, you need two numbers that would multiply to give me -6 and would add to give me 1. And the two numbers are 3 and -2. So then the two factors are x plus 3 and x minus 2. Now, after I write it as a factored form, I have to check, do I have a factor in common? Yes, I have the x plus 3 to be in common. So that factor that I canceled out is going to give me the x of the whole. So I set it equal to 0. I get that x is equal to -3. It means that the whole of this function will have an x of -3, and I will find the y in a minute. How do I find the y? Let's see what's left. So what's the simplified form? I will have 4 over x minus 2. In this case, I have to plug in the x I just found over here, the x coordinate. I have to plug it in the simplified form. So I will get 4 over -3 minus 2, which is 4 over -6. If you try to simplify that by 2, so it's going to be 2 over -3. So -2/3, that's going to be the y coordinate. Now if you go ahead and plot that, -3 and -2/3, so and -2/3 is going to be somewhere over here, so let me zoom in. It's -3 and -2/3. Okay, so remember, to represent the whole, you have to have an empty circle. And then remember, when you're graphing, you have to skip that point. And that's going to be the point -3 and -2/3. Now, as for the vertical asymptote, it's the factor on the bottom of the fraction that you didn't cancel. And you set that equal to 0. So x minus 2. So x minus 2 equal to 0. And then if you solve for x, so x is equal to 2. And that's going to be my vertical asymptote, which is a vertical line. So let's represent that with a red line as well. So at x equals 2, I'm going to have a dotted line. Then I will remember that my graph should come so close to this asymptote, but never touch it. So that's my vertical asymptote. Now let's move on to the x-intercept. The x-intercept is, to solve for the x-intercept, you set the top of the fraction equal to 0. So 4 equal to 0, which is impossible. It means that I do not have x-intercepts. So it means my function is not going to touch the x-axis. And it does make sense, because the x-axis in this case is what? It's the horizontal asymptote. So my function is not going to touch it. We already know that. Okay, now let's go ahead and graph our function. So what I'm going to do, so I know my function will belong to this part, so I have to go ahead, connect it, see how I skipped this point, because there's a hole in this function. And then I continue graphing. See how I'm coming closer to the asymptote, but I'm not touching it. So that's going to be the first part of the graph. The second part of the graph is going to be on the other side. So again, since I don't have a point, but I do have the asymptotes, and I know that my graph will come so close to the asymptotes, but will never touch it. So these two parts represent the graph of my function. Okay? Now to find the domain, remember it's from left to right. And you always skip the x-coordinate of the whole and the asymptote. So the x-coordinate of the whole is going to be -3. Keep that in mind. So I'm going to skip -3 in the domain. And the asymptote is at x equals 2, so I'm going to skip also 2 in my domain. So this is going to be a domain made up of 3 different parts, going from -infinity to the x of the whole, and then from the x of the whole to the asymptote, the vertical asymptote, and then from the vertical asymptote to infinity. Let's see how this is being represented. There you go, from negative infinity, and then you jump. So that's the first split in my domain. And you continue, as you can see, you are not going past this vertical asymptote, so that's your second split in the domain. And then your function picks up from number 2 all the way to plus infinity. Now the range is going to be also the same thing. You have to go down from the bottom all the way up until you get to the whole of this function. You skip and you move on, but you don't go past this horizontal asymptote. So that's 2 skips so far. And then you pick up from the horizontal asymptote all the way up to plus infinity. So we have to look at the y of this whole. So the y was, negative 2/3. So that's negative 2/3. That's the first split in my range. And then I have a horizontal asymptote at y equals 0, and that's going to be the second split in my range. So then my range is going to be from negative infinity to the y of the whole, then from that y coordinate to the horizontal asymptote, then from the horizontal asymptote all the way to plus infinity. So remember, to get the range, you have to look at the y coordinate of the whole of the function and the horizontal asymptote. For the domain, you look at the x coordinate of the whole of the function and the vertical asymptote. Now let's go ahead and look at end behavior. To find end behavior, you have to look at your horizontal asymptote, and I do have a horizontal asymptote at y equals 0. Then my answer will be at 0. Now let's see how this is represented. As x tends to negative infinity, it means you have to look at the left side of your graph. If I look at the left side of my graph, as you can see, it's getting closer and closer to the asymptote. So then y is getting closer to 0. So f of x is getting closer to 0. F of x means y. Now let's look at the right side of my graph. The right side of my graph, as you can see, as you're going to plus infinity, or you're going to the right, it's getting also closer and closer to the horizontal asymptote. So I know that the y is going to be getting closer to 0. Now that's everything for this lesson. I hope this tutorial was helpful.